So hello everyone, today we're going to present our final project on replicating the reimagining price trends paper. I'm Edwin and I'll start with the introduction. So as we all know, traditional technical analysis is quite constrained, and in order to capture unseen predictive patterns and complex relationships between price data and volume, the author of the paper proposed a novel method of using image data to train a CNN model to predict whether the price of a stock will go up or down in the future. And we replicated the whole paper from start to end. We used the data preprocessed by the author, which includes price data of US stocks from 1993 to 2019, and for the model we used a 3-layer CNN with ReLU as the activation function. We also adopted all the optimization and regularization methods proposed by the author to ensure comparability, such as Cherry weight initialization and batch normalization. The respective advantages are listed below. We achieved similar results as the paper as seen on the table. We achieved a similar accuracy, especially on the 60 days return prediction with a high F1 score and recall. As for the return and Sharpe ratio, the results are even more close, and we can see a clear monotonic relationship between the predicted probability and return. And we also have the same observation that the long-short portfolio has the highest return and Sharpe across different time horizons, and these findings show that the model is able to extract economically meaningful signals from the images.
Case 3 is about robustness test. In this part, we follow the experimental design outlined in Appendix B of the original paper. We do the robustness test with respect to model structure and estimation choice. And we do some extent tests on optimizer, learning rate, and learning rate schedules. Here we use R20-R20 configuration as the example. From the result, we know that changes on activation functions and optimizer result in a significant degradation of strategy performance. Loss function values and accuracy is robust during the test by the metric of portfolio level fluctuates. This result highlight predictive accuracy and strategy performance do not always align. Next part is about model interpretability. Here is our model structure. This model explains how CNN rely on features during classification from local to global perspective and provide a semantical grounded interpretation. The first model is grad CNN, and the next one is sharply active explanation, and the third one is the testing with concept activation vectors. Okay, here is our result. We choose sample from 2017 dataset. As for layer 1, we know that model do not rely on prominent localized hoppers. For layer 2, we know that model forms predictions through accumulate weekend contribution across multiple channels. As for layer 3, we know that CNN is more sensitive to negative or risk-related patterns than upward price movements. Overall, the model demonstrates a highly distributed decision structure characterized by weekend localized activation and broad attribution distribution.
The original class slide treats this as a binary classification problem. The model only predicts whether the 5-day return is positive or negative. However, in the project description, the professor encouraged us not to stay with a simple classification task because the label field truly contain much richer information, continuous returns at several horizons, such as 5-day, 20-day, and 60-day. And for regression model, the data is same as a paper. And to evaluate these models, I run a unified long-shot backtest for each test day and each horizon. I predict the forward return for all stocks ranked them by the prediction, then go down the top 10% and short the bottom 10% with equal weight within each side. And as evaluation metrics, I look at actual returns and cumulative net curve over 2002 to 2020. So the results are that for 5-day, I say it's about 0.045 and total return is about 26 times. For 20-day, I say it's about 0.039, total return is about 19 times. For 60-day, I say it's about 0.028 and total return is about 22 times. So all three curves turn up upward, which indicates consistent predictive power across horizon. And in conclusion, we replicated and extended Jiang et al.'s financial images CNN using the original CRSP image that confirms that the CNN single tells us stocks into desires with monotonically increased returns and Sharpe ratios, although our absolute performance is lower. And robustness tests show that classification accuracy is quite stable, but economic meaningful metrics such as IC and portfolio Sharpe are very sensitive to architecture and training hyperparameters. Interpretability analysis with GradCam integrated gradients Sharpe and TCAM suggests that network makes decisions in a highly distributed way and reacts more strongly to downtrend and sideways partners than to strong uptrend. And extending the model to multi-horizon regression setup yields positive information coefficients and strong long-shot nav growth across 5, 20, and 60-day horizons, indicating that the learner visual features generate well across different prediction horizons.